quickly, we're going to cover the basics of absolute value equations. First, we have to know what the absolute value is, and that is a number's distance from 0 on a number line. So if I have a number line, the distance from 0 to 5 is 1, 2, 3, 4, you guessed it, 5. But if I want to see the distance between 0 and negative 5, I count 1, 2, 3, 4, 5. What we notice is that they both are 5 away from 0, and they're both positive. So the absolute value is always positive. Now let's say we have a problem. We are going to have the absolute value of x equals 11. So first of all, these bars are called absolute value bars. Anything I put in for x, whether it be negative or positive, will spit out a positive 11. So how do we do this? We take x out and we put it equal to 11, but we also want to put it equal to negative 11. As you can see, our solution is 11, negative 11. And that's how you would write your answer. What it's saying is if I plug in 11 into the and I take the absolute value, I'll get 11. But if I also plug in negative 11 into my absolute value, it'll spit out an 11. So these are our two possible solutions for this problem. Let's try one more. If I have the absolute value of 5z equals 40, well, I first take whatever's inside the absolute value and I set it equal to the numbers positive and negative form. So in other words, I take 5z and I set it equal to 40. That's the number they provided us with. But I also want to set it equal to the negative form of 40. Now I'm going to solve each problem separately. To isolate z, we divide by 5. Z equals 8. To isolate this problem, we divide by 5. Z equals negative 8. So z equals 8, negative 8. And that's our solution. So if I plug in positive 8 for z, I will multiply 5 times 8, get 40, take the absolute value, and you'll see we have 40 as our answer. So that works. If I plug in negative 8 for z, I'll have 5 times negative 8, which will give me a negative 40. But when I take the absolute value, I'm making that number positive. So we have 40. So both of those solutions will work.